description, we are talking about the continuous random variable x as a probability density function, something like this. We need to find the value of k. So now, in order to find the value of k, the first basic thing that we should be aware of is, so whenever we have a probability density function, the integral, the area under the probability density function for all possible x has to be equals to 1. And the area under the graph, so we can always find it using the concept of integral. So that is for all possible values of x, it's the integral of f of x dx, and this has to be equals to 1. And if I try to integrate this is going to be integral of, so for all possible values of x, here the function exists only between 0 to 1. So that's why it's 0 to 1 into k over square root of 4 minus 3x squared must be equals to dx. Must be dx. Sorry, multiplied by dx is equals to 1. Now, in order to integrate this, you need to know a rule. So that is integration of 1 over square root of 1 minus x squared is going to be just sine inverse of x. Of course, if you have 1 minus ax squared, some constant into x squared, so it's going to be sine inverse of ax and entire thing divided by a. So this is the rule that you need to be aware of. Now, in order to make it in that format, so I'm going to take 4 common out in the denominator. So when I do that, of course, it comes out of the square root. So k over square root of 4 into square root of 1 minus 3x squared by 4 into dx is equals to 1. And if I simplify this, square root of 4 is just 2. And k over 2, I can also take it outside. So it's going to be k by 2 into integral of 0 to 1. So 1 over, I can also rewrite the denominator as 1 minus square root of 3x over 2 the whole square. Of course, it has to be ax whole square, only then it would work. And I have it something like this. So now I can use that integration direct rule. So that's going to give me k over 2 times sine inverse of, in place of a, we have root 3 by 2. So sine inverse of root 3 by 2x and divided by root 3 by 2. Because we have divided by, these 2's can get cancelled out. So if I put the upper limit and the lower limit, also I can take root 3 common outside. So it's k over root 3 times. When I put the upper limit, so it's going to be sine inverse of, in place of x, I'm going to put 1. So it will just going to give me sine inverse of root 3 by 2. Then minus sine inverse of, in place of x, I'm going to put 0. So sine inverse of 0. And this must be equals to 1. So from here, we just need to solve for k. And we know the sine inverse of root 3 by 2 is basically, in terms of degrees, it is 60 degrees, but we should never write 60 degrees here because this, all these root 3 and everything is in, it does not have anything in the unit. So it doesn't have the unit something like a degree or something. So it is unitless. So that's why you should always use it in radians. In radians, root 3 by 2 is pi by, it's going to be pi by 3. Sine inverse of root 3 by 2 is pi by 3. And sine inverse of 0 is 0. And this is what is equals to 1. So when I solve for k, 3 into root 3 goes to the other side. So k times pi is equals to 3 root 3. So that's why the value of k is 3 times root 3 divided by pi. And this is the right answer for this sum. And here, if I talk about the marks distribution, the marks distribution goes something like this. So for showing this particular step, you will get 1 mark. And for integrating it, that is the step. So using the sine inverse rule, so you will get another mark. and substituting the limits, upper limit and the lower limit, you will be getting the third mark, and the final answer that would carry 1 mark. And this is how the 4 marks are distributed for this sum. Now, for part B, we need to calculate the expected. So whenever the probability density function is given, the expected we can find it using the formula of, for all possible values of x, it's going to be x times f of x dx. And here, that's why the expected has to be equals to integral of, for all possible values of x means it's just going to be 0 to 1, x times, and f of x is here. Now we have already got the value of k, so which we can substitute it. So it's basically 3 root 3 divided by pi, and entire thing divided by square root of 4 minus 3x square into dx. Now this 3 root 3 by pi, I can take it outside, and the remaining thing stays in. Or let me directly use the substitution method here. So of course, here you can integrate it using the method of substitution. So we need to take this 4 minus 3x square as u. So whenever we use the substitution method, the first thing that we should do is, in order to replace dx, I need to get what is dx in terms of du and stuff. So that's why we should always consider differentiating it. So when we differentiate it, it's du by dx is equals to differentiation of 4 is 0 and minus 3x squared means, so the derivative of this one has to be negative 6x. So from here, if I make dx the subject, so dx goes to the right hand side and this part comes to the left hand side, it's going to be du over negative 6x has to be equals to dx. Let's keep this thing in mind. And the second thing is, whenever we have a definite integral, so which means with the limits, whenever we have it with the limits, and if we are using a substitution method, the limits will also changes. So which means when x is 0, so u has to be equals to 4 minus 3 times 0 square, which is just 4. And when x is 1, u has to be 4 minus 3 times 1 square, which is just 4 minus 3, which is just 1. So in that case, my new limits is going to be integral of, the lower limit is 4. When x is 0, it has to be 4. And the upper limit has to be 1. And this x, I'm going to keep it as it is. And here I can take this 3 root 3 by pi outside. I'm going to do that at this step, 3 into root 3 over pi. Then I will be left with 1 divided by square root of 4 minus 3x squared. We are taking it as u into, and dx we are going to replace it with du over negative 6x. And here x and x can get cancelled out. So you can check whether your substitution is correct or not. So if your substitution is correct, so you should be getting some expression completely in terms of u. And this one, I can also take this negative 6 outside of this integral. So it's going to be 3 into root 3 over pi times 1 over negative 6. Then this 1 over root u, the square root of u, can also be written as u to the power of negative half into d. So from here, I need to integrate it and simplify it. So this is going to be 3 1s are 3 2s are. So I'll be getting negative root 3 over 2 pi. Yes, we can also say it like this. When I integrate this, this is going to be u to the power of negative half plus 1, which is half, and divided by half. And this 2 and this 2, you can cancel it out. Now, when I apply the upper limit and the lower limit, so we will be getting the answer. So it's negative root 3 by pi into, when I apply the upper limits, so it's going to be 1 to the power of half minus 4 to the power of half. So 1 to the power of half is just 1 itself. And 4 to the power of half is 2. So it's going to give me minus 1. So minus root 3 times minus 1 would be just root 3. So the final answer is just root 3 by pi. And that is the expected for this probability density function. And here the 4 marks distribution goes something like this. So 1 mark is for putting the formula correctly and substituting this function in it. And the second mark is for trying to solve it using the substitution method. So taking out this u and yeah, finding out du by dx and all these stuff. So this would carry 1 mark. And the second mark is for, let's say, integrating it properly, these steps. And the final mark is for the final answer. And here the integration part would carry 2 marks. And the formula and the final answer would carry 2 marks. So that's how the 4 marks are distributed for 7 part B.